Hi, this is Professor Carter. This is the first of 5 lectures, video lectures that we're going to be presenting on the neoclassical marginalist theory of production and distribution. The general framework is going to be based on the text that C.E. Charlie Ferguson, Charles Elmo Ferguson wrote in the late 1960s into the early 1970s. This is the third edition of his text that was written in 1972. It was published shortly after his death. And this is Ferguson, and this is his book, The Neoclassical Theory of Production and Distribution. The approach that Ferguson has is, I think, very useful in terms of understanding these matters, and the numeric examples that we utilize will, in many of these lessons that we're going to be putting up this fall semester 2020, will include the numeric examples that Ferguson has in his text. This textbook, the microtheory textbook, it's a textbook proper, and it's dated, clearly, but it's very pedagogically sound and useful for an understanding of the basics of neoclassical marginalist theory, at least in one particular way in which we understand them. So this particular lesson is not going to be, or this lecture here um, is not going to be on the Ferguson text as such, but the framework and the understanding certainly comes from that. And in subsequent lectures, we will certainly have that developed. So we have here, what we're going to be doing here is we're going to be developing the neoclassical theory of production and distribution. Neoclassical, marginalist, all right, marginalist theory of production, a theory of production and distribution. All right, theory of production and distribution. And distribution. All right, you can see here that I've penciled out the lesson, okay? And so I have this in some way complete and so that we can have as keen an understanding as possible of the material, right? And as always, I will make photocopies of this page, and I'll upload it with the content of the video. Okay. So we begin here. We're going to be doing this thing that's going to be called producer equilibrium. All right. It's also referred to as the choice of technique. All right. The argument here is that the producer equilibrium is that the producer is going to enter into a market, into the factor market, and that producer is going to choose the particular technique of production or the particular relationship between the quantity of capital and the quantity of labor. Capital and labor, they're considered as factors of production, is going to choose that particular technique that's going to, in this case that we presented here, is going to minimize their costs. Or get to the optimal output subject to the cost constraint. That's going to be the point that we're going to be making here. So what that is, that's the choice of technique. All right, it's also referred to in the literature, and if you were to go into a search, a Google search or whatever, just said neoclassical choice of technique, you're going to get this particular framework, because the argument here is a behavioral assumption, right? And this is what we see with the marginal approach, is that everything is a behavioral relation. It's the purposeful behavior that is evidenced. Supposedly, it's theoretical. It's not in fact. But the point is that theoretically, this behavior, this optimizing behavior, is both on the demand side with the utility maximizing consumer, as well as on the output side, or the supply side, with the profit maximizing or cost minimizing producer. Right, and so you have within the general neoclassical model an approach which is ostensibly more robust, right, in as much as that you have a minimal set of assumptions, i.e. the optimizing behavior, that can then be applicable to a range of different theories and perspectives, etc. There, on the heterodox side of that, there are those of us who argue that the paucity of the theory is problematic. But never mind, we'll talk about that. And in leading up to that, actually, we'll see that precisely when we start looking at the problems of capital that comes with the Cambridge controversies, right? So we begin with a production function. So that's going to be the point. So we're going to have producer equilibrium. Like any equilibrium in a market, there's going to be different functional relations. On the one side, we're going to have the production function, and on the other side, we're going to have the cost of production. That's going to be the point. And so when I talk about producer equilibrium, we're going to talk about what is going to be the equilibrium quantity of output that the producer is going to, what is the equilibrium quantity of inputs that the producer is going to choose, et cetera. And then related to the output, et cetera. But the point is that that's going to be a function of the cost side of it as well. So the equilibrium is going to bring two different functional relations into unity with one another, to equality with one another. And this particular approach here, or this part here, looks at the production function. All right, so we begin with a production function. So we have here our production function. Now, the production function is simply going to be a mathematical relation. Okay, it's going to say that newly created output, which we're going to call y, is going to be the net output in the macro relation, all right, is going to be equal to a function of the input of capital and the input of labor. Okay, where these are going to be the factors of production here. These are going to be the factors of production. All right, factor capital, factor labor. Here it's a physical sense. Is it money? Is it quantity? Et cetera. We're gonna consider more of a micro relation, but we're gonna be a little bit vague about this. So I'm just gonna here just talk about the quantity of capital, but it's gonna be in this particular approach simple one commodity models. But in any event, so we take the total differential of this. All right, just to become acquainted with how we're going to be approaching this differential. All right, so we take the total differential of this function. The y, of course, is going to be the dependent variable, and it's going to be a function of two independent variables. That means that the total change in y, or the quantity of y, is going to be, by definition of the total differential, the change in the quantity of capital multiplied by the partial change in output with respect to the change in capital. That's going to be the marginal productivity of capital, is how we're going to see the partial derivative here. We're going to be looking at the production function as continuous and differentiable, and we're going to consider the partials of capital and partials of labor, which is going to be here. Total differential, the quantity of labor, is going to be the partial change in output with respect to the change in the labor input, where the marginal product of capital, by definition, is going to be the partial derivative of output with respect to the capital input, and the marginal product of labor is going to be equal to the partial derivative output with respect to the labor input. Okay? Now we're going to be assuming that this is going to have diminishing marginal productivity, marginal productivity. All right, so we have here, we got diminishing marginal product of both factors. All right, so both factors of production are going to be assumed to have diminishing marginal productivity. Okay, so we're going to draw this. So we're going to take our production function here, which you can see has a single dependent variable. Of course, it's a functional relation, and two independent variables, but it's going to be a function that's going to be in three arguments. And so we're going to write those or express those in terms of our graph here. All right, so we're going to draw a two by two graph, but in three quadrants. All right, so this is going to be a two-dimensional graph. All right, but it's going to be in three quadrants. All right, which is going to be here. This is going to be this. Okay. All right, so you're going to put on the vertical, on the right-hand side of the horizontal axis, the positive quantities of labor. On the left-hand side, the positive quantities of capital. So that's going to be positive quantities, not going to be negative quantity in quadrant 2. And on the vertical axis, we're going to put our output y. Okay, and we're going to be assuming that the marginal product of labor is going to diminish. Okay, so if we have diminishing marginal product of labor, what that means then is that we have this. Okay, this is the total product of labor, which is going to be here. All right, so this becomes the total product of labor. Okay, And so then you're going to be looking at the contribution of the different doses of labor, right? So this is going to be the first dose of labor. This is going to be the second dose of labor. This is going to be the third dose of labor. And then in our production function, when we're looking only here at the labor side, the total product of labor, so you would say that the capital input in this sense is going to be held constant. This represents the quantity of the labor input, that's the quantity of output that's going to be associated with 1 unit of labor. This is going to be the quantity of output that's going to be associated with 2 units of labor. This is going to be the quantity of output that's going to be associated with 3 units of labor. Okay, which is going to be here. It's going to be here. Okay, this is going to be here. And what you're going to have here is the marginal product of the first dose of labor is going to be greater. The marginal product of the second dose of labor is going to be less. And the marginal product of the third dose of labor is going to be even less. You have diminishing marginal productivity on the labor side, and you're going to make the same assumption on the capital side. All right, so you're going to then have a diminishing marginal product of labor on the capital side as well. All right, and so this then becomes the total product of capital, and then you're going to have the same understanding or the same diminishing marginal product, the first dose of capital, the second dose of capital, the third dose of capital is going to then be here, first dose of capital, second dose of capital, third dose of capital is going to be here. Okay, and then with that, you're going to have here, okay, you're going to have here the functional form when you put the two together. All right, and then what happens then when you put the two together, you're going to have an even higher quantity of output, and we're going to be doing that in the next video.